All right, so today is going to be a continuation of our conversations on inequalities. We've done one-step addition, subtraction, and one-step multiplication, division inequalities. Today we're going to put it all together and we're going to learn how to solve two-step inequalities. So as you can see, our learning goal for today is just to solve two-step inequalities. And we're going to have to apply all of those properties of inequality that we've been working with and practicing on the last few days. So the first term and definition, the only term that we're going to have for this lesson is a two-step inequality. That is an inequality that contains two operations. To solve a two-step inequality, you're going to use inverse operations to undo each operation in reverse order of the order of operations. So very much like two-step equations, like for example when we had 2x plus 3 equals 13. If you guys remember back to, we would undo in backwards orders of operations, so it was SADMAP. I see in this equation here multiplication when the 2 is multiplied by x. I also see addition when I'm adding 3 to the variable term of 2x, which means I need to undo the addition first, so I subtract 3 from each side. That gives me 2x is equal to 10. And then I undo the multiplication by division, so I divide by 2, divide by 2. I'm going to write my answer out to the side because I know it cuts off when it's closer to the bottom. So I'm going to get x is equal to 5. Well, that's what we were doing. Now what we will be doing today is two-step inequalities. So I may have 2x plus 3 is less than 13. So again, we're going to carry out the same type of backwards order of operations. So I see addition and I see multiplication, so I'm going to undo that addition first, subtract 3 from each side. I get 2x is less than 10. I divide by 2 and I get that x is less than 5. So as before I had x was equal to 5, now I have x is less than 5. I have an inequality instead of an equality. So in this case, we can see the difference is very minor. We are going to need to remember one thing. I hope you're thinking ahead of me. Well, what do I do if the coefficient is negative? So we need to remember that you flip the sign. So you have to remember that you flip the inequality sign when the coefficient is negative. I'm going to abbreviate coefficient for coef is negative, and for negative I'm going to just abbreviate with neg. Okay? So let's try a few examples. Now today we're also not going to do any word problems because the day after tomorrow we're going to spend a day talking about word problems that are one-step and two-step, using the multiplication and division properties of inequality as well as two-step inequalities. But for today, let's focus on the two-step inequalities. So the first one, solve 2x plus 1 is less than 11, and then they also want us to graph it on a number line. So we're pretty much experts on graphing. We just need to continue to practice how to solve these inequalities. So we have 2x plus 1 is less than 11. So the first thing I need to do on each side, well, let's see. I'm going to SADMAP just so I can clarify for myself what operations I see. I see addition when I'm adding 1 to the variable term, which is 2x. And since my variable term does contain a coefficient other than 1, I see multiplication that I need to undo. So I'm going to undo the addition first. I'm going to subtract 1 from each side. That's the subtraction property of inequality. That leaves me with 2x is less than 10. I need to undo the multiplication, and what's going to help me with that is the division property of inequality. And I'm going to divide by 2 on each side. That's going to give me x is less than 5. So I need to graph that now. So I'm going to scale my graph by 2s just because my graph is kind of small. So I always want to put 0 in the middle as best as I can, and I always want to scale a few numbers in the positive side and a few numbers on the negative side. So since it's x is less than 5, I know that 5 falls between 4 and 6. Since it's a less than, that's an open circle. and I'm going to shade to the left. Okay? All right, let's try another example. 8 plus 3x is greater than 14. A great time for you to pause the video and try this on your own if you'd like. The worst that would happen is that you'd get the wrong answer and then have to try it again. Okay? So let's SAD map this one. So I see addition in the form of 8 plus, and I see multiplication in the form of 3 multiplied by x. So we're going to undo the addition first. I'm going to subtract 8 from each side. I'm going to have 3x is greater than 6. Undo that multiplication by dividing by 3 on each side. I'm going to have x is greater than 2. So when we go to graph this, get your number line, put 0 in the middle. I think I could scale this graph by ones. I'm going to have an open circle at 2, and since x is greater than 2, I'm going to shade everything to the right, which is bigger than 2. Okay? Hope we're getting the hang of this right now. Now here we have to be careful because I have the inequality 6 minus 3x is less than or equal to 9, and if you have an idea of why I'm saying we have to be careful, then I would suggest that you pause the video and again try to work ahead of me. Now, there's two things here that could throw us off. I have 6 minus 3x, but I see that this 6 is positive. So we don't actually have subtraction happening here. I have addition because that 6 is being added to a negative variable term. In other words, my coefficient to the variable is negative. I have 6 plus negative 3x is less than or equal to 9 whenever I use my properties of my sign rules, in other words. So I keep change, keep that 6 positive, add, and then change that 3x to negative 3x. So I have 6 plus negative 3x is less than or equal to 9, which means I'm actually undoing addition first. So I'm going to subtract 6 from each side. That's going to give me negative 3x is less than or equal to 3. And here's the next point at which I need to be really careful. I see that my coefficient is negative, so I'm going to be dividing by negative 3 on each side. Since I'm dividing by a negative on each side, that means I need to remember to flip my inequality sign. So I know that x is going to be greater than or equal to negative 1. So I go to graph. Again, I can scale my graph by ones. And this time it's going to be a closed circle at negative 1, and I'm going to shade to the right. Alright, so we do need to be careful. Anytime I see a negative outside of the variable term, I know that I'm going to need to flip my inequality sign. Alright, let's try one more example before we get to the problem of the day. X over 4 plus 3 is greater than or equal to 7. Again, we're going to SAD map here. I see that I have addition and division, so I'm going to undo my addition first, subtract 3 on each side. That gives me x divided by 4 is greater than or equal to 7. Then I need to undo that division. I'm going to multiply by 4 on each side. Since I'm multiplying by a positive value on either side, I do not need to flip my inequality sign. So my final answer is going to be x is greater than or equal to 28. So when I go to graph this, a good value to scale this graph by could possibly be 7s or 14s. I'm going to scale by 7s. So I know that's going to be 7, 14, 21, 28, 35, I'll give myself one more, 42. The other side I'll just give myself 3 values. I know it's going to be a closed circle since it's greater than or equal to at 28, And since it's greater than or equal to, I'm going to shade to the right. Alrighty, so that concludes our lesson. Here is our problem of the day for tomorrow. So for inequalities, this first one here is a little bit harder to read. It's -2 minus 3x is greater than -23. The rest of them are pretty easy to read. And then you have number lines. You obviously don't have to use the same number lines that are provided for you. You could draw your own number lines. And we'll go over these first thing in the class tomorrow. Be ready to put one up on the board for me. Have a great night.